right, hello everyone. We're looking at lesson 29. This will be our last bit of nomenclature before the next test, and we're going to look at acids. So with acids, there are two types. You have binary and ternary, and I can basically summarize it if we go right here. Let me actually pull up another one of these. I'm going to pull up both the periodic table and the polyatomic ion table. So let's find support materials. We'll have the polyatomic ion chart. And from here, let's go support materials. And we'll open up the periodic table as well. Here we go. So we have both of these. So basically, to make it simple, binary acids, well, really what an acid is just simply a hydrogen bonded to something else. That's really what makes an acid. Hydrogen bonds to something else. It's a positive hydrogen bonds to a negative ion. Now, if it's a positive hydrogen bonding to one of these polyatomic ions, it's called a ternary acid. If it's a positive hydrogen bonding to one of these negative ions off of the periodic table, one of these basic elements, then it's a binary acid. So if it's binary, which just means hydrogen bonding to one of these right here, then we're going to call it hydro and end it with ic acid. So whatever the name, say if it's chlorine bonded to a hydrogen, you would call it hydro and not chlorine acid, but hydrochloric acid. If it's sulfur, hydrosulfuric acid. If it's nitrogen, that one sounds weird, but it's hydronitric acid. If it's phosphorus, hydrophosphoric acid. So basically take the ending, cut it off, and replace it with ic acid. And take the beginning and give it a hydro. That's it. That's it for binary acids. So like right here, HCl, hydrochloric acid. HBr, hydrobromic acid. Now notice, you got to pay attention to the charges when you do these. Remember, everything in group 17 is a -1 charge. Everything in group 16 is a -2. And everything in group 15 is a -3. So like if it's hydronitric acid, it'll be H3N because it takes 3 hydrogens to balance this out. And nothing in the name is going to tell you di or tri because you can just use the charges to figure that out yourself. In the next class, when we do a review of all of this, I will give you harder questions where there's multiple choice and you actually have to pick which one is the right answer. So H2S for hydrosulfuric acid. That's binary acids. Okay. And then ternary acids, there's a little bit more to it. So first review what the polyatomic ions are. That's really just going to the support section and opening this. These are your polyatomic ions. Now what you're going to do, you're just going to put an H in front of these, 1 H if it's any of these with the -1, and then obviously 2 H's if it's any of these with the -2. If it's any of the ones with the -3, you have to put 3 H's in front of it. But you're putting a positive H's in front of these, and it makes what we call ternary acid. Here's how you name it, though. So it's going to be hydrogen, oxygen, another nonmetal, and the ternary acid comes from the name of whatever polyatomic anion you're using. So what you do, if the original ending had an 8, you don't put a hydro in front. Okay, make that very clear. Ternary, no hydro. So if you're using these, you just go ahead and name it. You don't put hydro in front. If you're using these, you have to use hydro in front. So with this, you're just going to, if the ending was 8, you just change it to ic acid. If the ending was ite, you change it to us acid. So bromite, if you put an H in front, it'll be bromic acid. Hypobromite, put an H in front, hypobromic acid. I'm sorry, I messed that up. Ite. I'm looking here, I'm putting my mouse over here and saying ite. What I just did was probably confusing. I was putting my mouse somewhere and reading something else. Let's go through what all of these would be. If it's HBrO4, it'll be perbromic acid. Remember, 8 becomes ic acid. If it's HBrO3, it's bromic acid. If it's HBrO2, it'll be bromous acid. Ite turns to us. And if it's HBrO, it'll be hypobromous acid. And then if it's just H and a Br without any extra O's, if it's just HBr, that's a binary. If it's H and Br, then we would say hydrobromic acid. So hydro tells you it's a binary and it's one of these alone. If you don't start with a hydro, it's telling you it's one of these. So that's how we do this. You just change 8 into ic, acid, change ite into us acid. So with this, HBrO4. Let's look at what BrO4 is. It's perbromate. 8 turns into ic acid. So this would be perbromic acid. HiO2. Let's find IO2 right here. It's iodite. So you name this iodous acid. Chloric acid. So let's find what chlorate is. Remember, because ic acid comes from an 8. So chloric acid, we look for chlorate, which is ClO3 with a -1 charge. So you put 1H in front of that. So chloric acid is just HClO3. Sulfurous acid. So if it's us acid comes from an ite. So look for sulfurite or sulfite. So here it is, sulfite. So we just put 2 H's in front of that, H2SO3. Why do I say 2 H's? Because it has a -2 charge. So it'll be H2SO3. All right, so now what I want you to do, I want you to pause this, and I want you to try to go through these and try to answer the 2 questions, each with a set of 5. Answer these. So press pause, answer these, and then go ahead and press play and come back. Okay, number 1, HF. So all of these, because they're binary, start with a hydro. So hydrofluoric acid. HTE, hydrotelluric acid. HCl, hydrochloric acid. H2SE, hydroselenic acid. HI, hydroiodic acid. Why do some of them have a 2 and some of them have a 1? If you look on the periodic table, you'll notice that the F, the Cl, and the I have -1 charges because they're in group 17. The TE and the SE have -2 charges because they're in group 16. And that tells you how many H's it requires to balance them. Each H has a +1 charge. Okay, ASO4. With this, you might want to go over here and look. So you find ASO4, and ASO4 is right here, arsenate. So remember, 8 changes to ic acid. So this right here is just going to be arsenic acid, right here. C2H3O2, let's find what that is. Right here, acetate, so change 8 into ic acid. So that will be acetic acid. So this turns into acetic acid. And there we go. Let's take H2CO3. So we find CO3, which is carbonate. So change carbonate into carbonic acid. So let's find carbonic acid. There we go. HNO2, where's NO2? Right here, it's nitrite. So you change it to nitrous acid. Nitrous acid. Remember, ite becomes us acid. And then lastly, H2C2O4. Let's find C2O4. Oxalate has 2 H's in front because that's what it takes to balance the -2. So change 8 into ic acid. So oxalic acid. So oxalic acid. There we go. So these, when you have it like this and you have to match it, it's the simplest, easiest version of this. And that's what I've been giving you for all of these. Tomorrow for the review, what I'll do is I'll just give you something a little bit harder because I'll give you just this, for example, and then I'll give you 4 options. So you have to make sure you're doing it right. So tomorrow we're going to review all of it, and we're going to do a harder version, which will get you ready for what's going to be on the test, which will be the day after. So do your best on this. As always, contact me if you have any questions or concerns.